Okay, so what we're going to look at is some mass mole particle conversions, which we covered in class last block. So remember, when we are looking at these type of conversions, there are three conversion factors, or three quantities you need to know to be able to convert one to the other. You need to know that 1 mole is the same as 6.02 times 10 to the 23rd particles, is the same as the mass in grams from the periodic table. So in any given problem, I'm going to use two of those three values, make them an equality, and then use that equality to come up with a conversion factor to solve for what I'm looking for. So for the next three examples, I'm going to use nickel 2 chloride. So it's probably useful before we even start to look at what is the molar mass of nickel 2 chloride. If I go to the periodic table, nickel is 58.69 grams, and chlorine is 35.45 grams, and there are two of them. So when I add those up, I get 129.59 grams, which is the mass of 1 mole of nickel 2 chloride. So the number that goes here for this set of problems is going to be 129.59. So let's look at this first question. How many grams are in 0.683 moles? Well, 0.683 is my known. Grams is my unknown. And so for my conversion factor, I need to convert moles to grams. So I need to pull the mole, and I need to pull the gram. So those are the two parts are my conversion factor. Those are the two things I will use in the conversion factor. So 0.683 moles is my known. When I look at my conversion factors, 1 mole of nickel 2 chloride is 129.59 grams of nickel 2 chloride. How I knew to put mole at the bottom is because the units in those diagonal boxes need to be the same, so they will cancel out, because remember, this line, horizontal line, represents division. So when I go to do the math for this, it's going to be 0.683 times 129.59 divided by 1, which to three significant figures is 88.5 grams of nickel 2 chloride. So three significant figures in my answer because my starting quantity also had three significant figures in it. So now let's look at a different conversion, again using nickel 2 chloride. Here, my unknown is moles, and my known is formula units, which is a particle. And that is my known. So what that tells me is I'm going to use these two conversion factors. So I don't even need to know the molar mass of nickel 2 chloride. I don't even need a periodic table. So if I take my known and put it in the first box, when I go to set this up, I know that particles have to go on the bottom because formula unit is my particle. So that would be 6.02 times 10 to the 23rd formula units. And that is the same thing as 1 mole. So those units cancel out. And so 2.54 times 10 to the 19th times 1 divided by 6.02 times 10 to the 23rd. There's my math. If I put that in the calculator, and to three significant figures, because remember in scientific notation, the decimal part is the significant figure part, that comes out to 4.22 times 10 to the -5th moles. So since I'm dealing with moles and particles, formula units in this case, it doesn't even matter what the formula units are of. So if I have 2.54 times 10 to the 19th particles of any type, I would have 4.22 times 10 to the -5th moles of those particles. For the last question, we're going to work from from moles to grams. So now, in this case, mole is my known, grams are my unknown, which means I'm going to go up here and pull those two again, which means I do need to remember from the first slide that the molar mass of nickel 2 chloride is 129.59 grams. So my question says I'm starting with 4.49 moles of nickel 2 chloride. So when I go to plug my conversion factors in, I know these need to be the same. So that's 1 mole on the bottom. And then on top is going to go my grams, 129.59 grams. And to 3 significant figures, that gives me 582 grams. And the math behind that is to take 4.49 times 129.59 and divide it by 1. So you can see, because this conversion factor is an equality, I pick the 2 things I need, and there's no set which one goes on top, which one goes on the bottom. It depends on what my known is. If my known is moles, then moles go on the bottom. If my known is grams, then grams go on the bottom. So it's really important that you keep track of the units as well as the numbers when you do these type of mole mass particle conversions.